Welcome friends. In today's video we will discuss about the properties of determinant with examples. So let us look the first property of the determinant. It says that the value of a determinant remains unaltered by changing its rows into columns and its column into rows. Basically what it means that, let us take an example. Let us consider a matrix 3 2 5 1 2 3 5 3 9. Okay, sorry, this it is the sign of matrix. Okay, this is the sign of determinant. Okay, so this is the sign of determinant. We can represent it as this. Now the value of a determinant remains. Okay, we now have to find out the value of this determinant. Okay, what is the value of this determinant? Do you know how to calculate the value of the determinant? Okay, I am telling you. At first we should write -1, then this is the first row and first element we are taking. We are expanding, we have to write expanding by the elements of first row. Okay, it means that we are expanding by this row. We can also expand by column. Okay, so we have to write this, and this is the I plus j. Okay, we have to write in this. Okay, 1 plus I plus j. Okay, to the power we have to write it to the power I plus j. Okay, so this is 1 plus 1. It means it is first row and first column element, so you have to write down this, and this is 3. We can write its minor, or we can directly calculate it. I am directly calculating it by eliminating this row and this column. 2 3 3 9. It means that 2 9 are 18. We have to first take principal diagonal element, so it will become 18, and this is the -9. Okay, now again plus, we will be taking, this is the formula. Okay, -1. Remember one thing, in the matrix, in determining the cofactor of matrix and the determinant, to evaluate the determinant in these two cases we need to use this formula. Okay, so let us start that. So this is the first row and second column, so this will become 1 plus 2 and into 2, and eliminating this row this column. 1 3 5 9, so 9 ones are 9, minus 5 3s are 15, again -1 1 plus 3. This is first row, third column. 5, eliminating this row. 1 2 5 3, so 3 are 3, and 5 to 10. So -1 square equal to, we know that, +1. Okay, so this will 3 and become 3 into 9. This will become minus. Okay, plus into this is -1, this is plus, so eventually it will become -1. Now -1, and this will become -6. Okay, minus is -12 and -1, so it will become +12, and this will become plus. Okay, -1 to the power 4, so it will become +1, so the value will be unchanged, 5, and this is -7, so 27 plus 12 minus 35, so it will become 4. Okay, now if we interchange row column, okay, sorry, not interchange, changing its rows into column. Okay, what we will get that 3 2 5, this is 5, and this will remain as it is. These 4 values will remain as it is. Now if we calculate that, you will see that I am calculating it directly. Okay, so it will consume less time. Plus 1 to 3 to 5 minus 9 into 2 plus 5 2 into 3 minus 25. You can evaluate this, okay, in the same method. Okay, you can evaluate this in the same method. So after calculating it, you will find that this will become also 4. So eventually these two values become same. So the first property is verified. Okay, the value of a determinant remains unaltered by changing its rows into column and its column into rows. Okay, second property is the interchange of any two columns or any two rows of a determinant changes the sign of the determinant without altering its numerical value. Okay, what it means that let us take an example again. This is a very important properties of determinant. Okay, please remember these formulas. So okay, let us do a thing that let us interchanging first column and third column. Okay, so what we will get here, basically this will become 539, this will remain as it is, this will become 315. So this the value of the determinant, okay, and the value of the remaining determinant, okay, what we get is 4. You can verify it. Okay, you can verify it. Look at this, we have taken this before. Okay, so this value is, we know this is 4. Okay, let us elaborate this. Okay, evaluate this. So this will become minus 1 plus 1 5 minus 3 plus minus 1 plus 2. This is the correct rule. Okay, it will never go wrong. So I will suggest you to do in this form. So what is this? 15 minus 9, this is minus 1 plus 3, this will become 9 minus 18. So this is plus 5 into 7, this is minus. Okay, so minus, and this is minus 9 6, so this is become 12, and this is minus, so it will become minus 12. This is plus, it is minus 27, so 35 minus 12 minus 27. Okay, let us check it. 3 and minus 9 minus 3 minus 27. Okay, 35 minus 12, it will become 35 minus 25, so 23 minus 27, it is minus 4. Okay, so our property is that the interchange of any two columns or any two rows of determinant changes the sign of the determinant without altering its numerical values. Okay, so its numerical values are not changing, because this is 4 and this is 4 too, but the sign is changing. Okay, so this is an important property of determinant. Okay, if we interchange the rows and column, the sign will get changed. Okay, but the answer will remain same. Okay, now if the determinant has two rows or two columns identical, its value is 0. What it means, two rows or two columns identical? It means that three, 1, 5, 0 0 0 0 0 0. Its determinant value is basically 0. Or let us take another example, okay, where identical means not always it it will remain 0. Okay, it may become that p p q r 3 2 1 2p 2 q 2 r. Okay, it this is you can look at this. Okay, this is a scalar, so it is multiplied by pq and r. Okay, but pq are identical, so this value and this value is identical. Okay, so it will, the answer will become 0. If you elaborate it, if you evaluate it, it will become 0. Okay, so in case of determinant, in any row or in any column, we can multiply with the scalar. Okay, but in matrix, if we multiply with the scalar, we need to multiply with every element of that matrix, but not in the case of determinant. Okay, so this is an important formula, important rule, okay, important property of a determinant. Now the fourth is, if every element of any row or column of a determinant multiplied by some constant, the value of the determinant also multiplied by that constant. It means that the value of the determinant is multiplied, not necessarily all the elements we need to do multiply. Okay, we not need to do that. Okay, so let us take this. Let us take the first example. We have taken, this is 4. Okay, I am not writing it again. This value is 4. We have taken this determinant. Okay, so if we multiply this determinant with 5, okay, with 5, but we are multiplying this by the second row element. Okay, so what will it become? 3 2 5 5 10 15 5 3 9. Okay, so in the answer we can multiply this to this value, so it will become 20. Or if we multiply this, the answer will become 20. Okay, so not every element is multiplying, but only a single row or single column can be multiplied in case of determinant, and the value will remain. Value will be multiplied also by 5. Okay, so this is the basic rules, basic properties of determinant. Okay, we have discussed. In the next class we will discuss about some problems.